Welcome to the complex variable and transforms course. We are studying complex arithmetic, the arithmetic of complex numbers, and today we'll prove a very important equation that the magnitude of the product of the two complex numbers z1 and z2 is equal to the product of their magnitudes. Right. So z1 is given to be x1 plus j by 1, z2 is x2 plus j by 2, two complex numbers, and we'll start from the left hand side and we'll end at the right hand side, and we'll prove that left hand side is equal to right hand side. Right. So first we have to multiply two complex numbers z1 and z2, and then we have to compute their magnitude. So z1 times z2 is x1 plus j by 1 times x2 plus j by 2, and you multiply x1 with x2, x1 with j by 2, j by 1 with x2, and j by 1 with j by 2. And you know that when we multiply j by 1 with j by 2, it becomes j squared by 1 by 2. J squared is minus 1, therefore I put a minus here, minus y1 by 2. And then we can collect the real terms together or imaginary terms together. So x1, x2 minus y1, y2, and we have put the real terms together, and here we have here we have collected the imaginary terms jx1 y2 and jx2 y1, right? And once we have done that, now it's time to compute the magnitude of z1 and z2. So given this, we know this is a real part, and this is a real part, the imaginary part, and when we compute the magnitude, we square the real part plus we square the imaginary part, and we have a whole square root. So the square of the real part squared the imaginary part, the whole square root. Right here, and this is a minus b squared, a minus b squared. We studied in school, a minus b squared is a squared minus 2ab plus b squared. So x1 x2 squared minus 2x1 x2 y1 y2 plus y1 squared y2 squared, and this is a plus b squared, so it comes out to be a squared plus 2ab plus b squared. So x1 y2 squared, x1 squared y2 squared plus 2 times the whole x1 y2, x1 x2 y1 y2, and x2 squared by 1 squared, the whole square root. And we see that these two terms can cancel because this minus is plus, and we can rearrange terms in such a way that we have x1, the terms having x1 we have written here, and the terms with y1 we have written here. And why? Because we want to take this x1 squared common. If we take x1 squared common, this becomes x2 squared plus y2 squared, and if we take y1 squared common, this becomes x2 squared plus y2 squared. And out of these two, x2 squared plus x2 squared plus y2 squared can be taken as common, plus multiplied by x1 squared plus y1 squared, the whole square root. Right. And we know that x2 squared plus y2 squared, and this square root can also be written as x1 squared plus y1 squared, the square root, times x2 squared plus y2 squared, square root, because a times b, we have a square root of a times b, we can write it as square root of a and times square root of b. So this is what we've done here. These two are being multiplied, this a, this b, the whole square root. This means the square root of a times the square root of b, right? And we know that this is x1 squared plus y1 squared, the whole square root is the magnitude of z1, and this is the magnitude of z2. This is equal to the right hand side. So we have proved that for any two complex numbers, the magnitude of their product is equal to the product of their magnitudes. Right. That's all for this small lecture. Thank you.